Well, let's do some adding and subtracting of rational expressions. Okay. The average cost per item in dollars to make X video games is given by this function. M of X equals 5 times X plus 1,000 divided by X. So that's the average cost per item, so per game. And the average cost per item to package the same game is given by P of X, which is 2 times X plus 50 divided by X. So we're going to make the game and we're going to package it. Okay, so we have two rational functions. And we want to write one function, C of X, that gives the total cost per item of making and packaging. So this would be a reason that we would want to be able to add two rational expressions. Okay, so let's take C of X is going to be the cost of making it, average cost per item, plus the average cost per item of packaging it. All right, and then we can combine those together. Since they have the same denominator, we would have 5x plus 1,000, and then add that to 2x plus 50 all over the same denominator. Then we'll combine like terms. The 5 and the 7 becomes, or 2 becomes 7, the 1,000 and the 50, and then we divide that by x. So this is going to be the total cost. And it says, okay, let's use your function. This is my total cost. Let's use your function to find the cost of making and packaging 50 games. Okay, so they're asking for C of 50. So of course I just plug 50 in where the x's are. And if I simplify that, okay, I will get 350 plus 1050, and 1400 divided by 50 is going to be 28. 28 what? Well, it's the cost of making and packaging 50 games, and that's going to be dollars. Okay, so $28 is the cost. All right, so you can see that we do need to add and subtract rational expressions. So let's just talk about the steps. So the steps for adding, first of all, least common denominator of all the denominators, and that's going to require us to factor. If necessary, build up each expression so that the denominators are the same. Then once you have the same denominator, combine the numerators using the properties of adding and subtracting fractions. And last thing you do is simplify the resulting rational expression as much as possible. And again, we may need to factor as well. So let's see what this is about. We're just going to do non-algebraic fractions first, just to remind us how to do the fraction rules. So we need to get a common denominator. The least common multiple of 5 and 4 is the number, of course, that 5 and 4 both go into. And 5 times 4 is 20. It happens to be the smallest number. So we're going to times, we would like to have these both over 20. And then once we have the same denominator, we can add them. So we'll times these both by 4, so we'll get an equal fraction, 8 over 20. We'll times these both by 5, so we'll get an equal fraction, 15 over 20. And then once we have the same denominator, we can just combine our numerators, okay? And in algebra, we don't change that to a mixed number. All right, so it so happens that if I factor 6, I get 3 times 2. And so the common denominator is, looks like they both have a 3, but they also both need a 2. So the common denominator is going to be 6. All right, well, this one has a 6, so we're going to keep that 5, 6. But this one, we need to times it by 2. So we need to times the top by 2. And then once we have the common denominators, we can 5 minus 4 all over 6, which is 1/6. All right. Again, we'll use that same idea where we're going to factor the denominator. So here we have 18 is, let's see, 2 times 9, but 9 is 2 times 3. So we have a 2 times a 3 times a 3. And 12 is 2 times 6, but that's 2 times 2 times 3. Okay, I'm doing it this way because it really helps when we do the algebra. So it looks like I need 2 3s and a 2. Okay, well, I've got only 1 3 and a 2. And, oh, I need 2 2s. Okay, so the least common denominator is going to be what they both have. So I need to have 2 3s and 1 2 and another 2. So I'm going to have 2 3s and 2 2s, if that makes sense. Okay, so if I have 2 3s and 2 2s, that is 3 times 3 is 9 times 4 is 36. So all that little work right there went into just finding the common denominator. Okay, so I'm going to go a little bit over here then. So then 36 is my common denominator. And if I times 18 by 2, then I'll get 10 over 36. And 12 times 3 minus 21 over 36. And now 10 take away 21 is, that's negative 11 over 36. Okay, so all of this work in here and down here, that was just a way to get the common denominator, to show you that by factoring, you can do that easier than just trying to guess and check. All right, let's see how that works with algebraic fractions. All right, so first we'll do a fraction that has a common denominator already. So we see the denominator is d squared minus 36. So let's just keep it d squared minus 36. And then we're going to take our d minus 6. Okay, well, that you say that's too easy. Well, we always have to make sure that we can't simplify this. Now, as it turns out, if you factor d squared minus 36, that's the difference of two squares. So that's the d plus 6 and the d minus 6 over the d minus 6. Now, we know that that is an implied factor when there's parentheses around it. So if we cancel those two, that leaves us with 1s. Our final answer is 1 over d plus 6. And since there's one variable, we better say that d cannot equal 6, because that's the factor we canceled. Okay. All right, here's a couple more. All right, this one, now these are different denominators. Okay, so we have to get the common denominator. So this is 10 times x, and this is x. So we need the least common denominator of both of them. That means we needed both a 10 and an x. So our common denominator is going to be 10x. I'll write it twice. Some students like to write it twice first and then combine them like this, and some students just combine them. You decide how you like it. Well, this one over here is just fine. I'm not going to do a thing, but this one needs to be times by 10, and what we do to the bottom denominator, we do to the numerator. So we'll get 100 over 10x plus 1 over 10x, which gives us 100 plus 1. See this step. So you decide if you like to show it separate and then together, but the final answer is 101 over 10x. Okay. All right, let's try this one over here. So if we have a whole number, we always put that over 1. Okay, and then we think of x minus 6, that's one factor. So really all we need is an x minus 6 over here. So our common denominator is going to be what we have, which is x minus 6. So I'm going to put that in 2, and then you can, like I said, I'm going to do it both ways, and if it's driving you crazy, just put them in 1. Okay, so here our 30 is already 30, but this one we need an x minus 6, and so we need to times both of that by x minus 6. So now we have minus 4 times x minus 6. Okay, so if you put it all in 1, just be careful about skipping steps, because what can happen is you don't forget, you need to distribute that negative to both of these when we simplify it. Okay, so this will become 30 minus 4 times x, and then negative 4 minus 6 is plus 24 all over x minus 6. And the last thing we do, once we have the common denominator and we've put the numerators together, then we simplify that numerator, 30 plus 24. So that's going to give us 54 minus 4x over x minus 6. You may need to factor the numerator, and just to be safe, to see that it can't be simplified. Both of those have a 2, 27 minus 2x over x minus 6, and there's nothing here to cancel. So this would have been okay, and this would have been okay for answers. All right. Okay. Let's look at a couple more with common denominators now. Okay, so this 6 has a 3 and a 2 and an x squared, and this 9 is a 3 and a 3 and an x. So what I need to do is I need to get two, so look at them one at a time. I need 2 3s, 1 2, and x squared. That will cover. I can't just have one x. So I need 2 3s, 1 2, and an x squared. That's my common denominator, what they both have. And that turns out to be 9 to 18x squared. All right, so that's just how I'm getting the common denominator. So what is missing with 6 times x squared? And that is 18x squared. So I would need to times that by 3, because what's missing is the 3. See how we need 2 3s, so I need to add one more 3 there. So times that by 3 and times this by 3. And I get 3 over my 18x squared. Okay, and then you look at this one, you say, okay, what's missing? I got 2 3s, I've got one x, I'm missing the 2 and an x. And so I'm going to times the 9x by 2 and x, and that gives me 8x, 4x on the top. Now I can combine those together, and I'll get 3 plus 4x all over 18x squared. And 3 plus 4x cannot be factored, so I can't cancel anything, so that's that. Okay, so now let's look at this. We have x minus 1 is all one factor, okay, can't be factored. And we have 4x. So really, we have x minus 1 and 4 and x. So really, we need all of these. We need a 4, we need an x, and we need an x minus 1 in our denominator. A 4, an x, and an x minus 1. A 4, an x, and an x minus 1. Okay, and so let's see. We've got the x minus 1. We need the 4 and the x. So 4 times x times 4x times 3, that's 12x. We'll keep our minus. Here we have the 4 and the x. We need an x minus 1. So we need 5 times x minus 1. Okay, so now we'll combine these together. So we have 12x minus 5 times x minus 1 all over 4x times x minus 1. And let's simplify the numerator, squish it all up. So we'll distribute that negative 5, and we'll get 12x minus 5x, and a negative 5 times a negative 1 is plus 5, all over 4x times x minus 1. And we'll simplify the numerator to get a 7x plus 5 over 4x times x minus 1. And the numerator cannot be factored, so we are done. Okay, let's pause this video and continue in the next one.